Good morning, class. We're on Chapter 3, Lesson number 5, Multiplication. And we're going to start on page 130 as we read. We have a photograph here. It was taken during the flight of Apollo 11 and shows the Earth from the distance of approximately 240,000 miles. The surface of the moon is in the foreground. So typically we're used to seeing it the other way around. We see the moon from the Earth. Well, we get to see the Earth from the moon. The Earth and the Moon are moving apart at a rate of about 4 feet each year. This means that 1 year from now, the Moon will be 4 feet farther away from the Earth. 2 years from now, it will be 8 feet farther away, and so on. The increase in distance between the Earth and the Moon is a function of time. Now, we've done this before. We've shown how over time something could increase, and we see here we can represent the function with a table, and we see the table here with time in years, the increase in the distance of feet. So when we start at 0, point of reference, let's say that would be today. Well, it is not 4 feet farther, it's simply 0. But in 1 year, it will be 4 feet farther away, and in 2 years, it would be 8, and in 3, it would be 12. Or we can also use a formula, letting x represent the time and y represent the increase in the distance. The formula is y is equal to 4x. As we can see, when we put in the values in, we put 0 in. Obviously, we're going to get 0 again, because again, that's today. That will be the present time. But in 1 year, when we multiply by 1 year, it will be 4 feet farther, and we multiply by 2 years, it'll be 8, 3, it would be 12, and so on. Now, and we can also see there's a graph over here. Because this function is a direct variation, its graph is a straight line that intersects the origin. If we draw the line and extend it into the third quadrant, we get the graph that's shown in the left. Now remember, the third quadrant is in the negative side, let's just say. We went over these graphing in the graphing lessons. We first started in the first quadrant, we moved into the second, third, and fourth, and we see the third quadrant is the one below the x-axis and to the left of the y-axis, and we can see here and it's going downward as we go backward. Okay, it's going upward as we go forward. Okay, and we're going to continue reading here on page 131. And just to go, this is going to go back into that graph. If we were to use a more complete table for the function, we have here negative values, -3, -2, -1, and then we have the continuation, which was the other table we had. So at -3, we see -12. -2, we see -8, and -1, we see -4. Now, notice that negative x numbers represent times in the past. Now, we've discussed this. When if I were to start with today and say 1 year ago, going back in time, I would have to say -1, and then 1 year before that would be -2 years from today, and then 1 year before that, it would be -3. So we can represent time in negatives if we're using a point of reference of today and going into the past. As we go into the future, we're going to use positive numbers as we use. So if you were to just look at the table and we see 0 and 0, that would be the present time. Okay, so that's where we are today. But 1 year from now, we know that the distance will for the Earth from the Moon would be 4 feet farther. But if we were to say we're going to go back 1 year and say this point last year at this time, what was the distance? Well, it was -4, or at least it was 4 feet less, okay, because it would have been closer. Okay, so we can continue to read on. And we notice that the negative x numbers represent times in the past, and negative y numbers represent decreases in distance. 3 years ago, the Moon was 12 feet closer to the Earth. 2 years ago, it was 8 feet closer, and so on. So we're using the term closer, farther and closer. Why are we using these terms? Because we can understand that. We know that the moon is farther. That means it's farther distance and it's closer. But as it relates to the present time, then we would have to use a positive and a negative to represent that. And in this case, we would say that the distance relative today is either positive, meaning farther, or negative, meaning closer. Okay? So, our formula says that each y number is always 4 times the corresponding x number. Okay, we see that in the graph. The y is always 4 times 4 times the corresponding x number. So we would always multiply by 4. That's our constant, as we call it, and you'll learn the term coefficient later on. In these examples, the product of a positive number and a negative number is a negative number. This is always true. So we look at this and we'll go, so which means that we have negative 12 is equal to 4 times negative 3, and negative 8 is equal to 4 times negative 2. The product of a positive number and a negative number is always negative. Now this is just standard math. We need to understand this and know it. When I multiply a negative and a positive, the answer is always negative. Obviously, we know that when we multiply a positive and a positive, we know that the answer is positive. Let's go here to our board. So when we've been doing this all of our life. Positive times positive, okay? So now we're going to have a negative times a positive, okay? And we're also going to have, excuse me, conversely, a positive times a negative, which is pretty much the same thing, because I can say 2 times 3 is equal to 6, as much as I can say 3 times 2 is equal to 6. So now this would yield a positive, this would yield a negative. And so would this. This would also yield a negative. All right, so we have to remember negative, positive, always negative. Positive, negative, always negative. And again, these are interchangeable. We can move these around all we want. Same with the positive. And then we're also going to learn, might as well put it up on the board, that when you multiply a negative times a negative, that's going to yield now a positive, okay? Now the easiest way to remember that is to maybe move this back up here. And let's see. I'm going to pop it up here and say negative times a negative is going to yield a positive. And maybe the easiest way to remember this is that if the signs are both the same type, then it's always going to yield a positive number, right? You see those two are both positive. And if they're opposite signs, whether it's negative, positive, positive, negative, it will always yield a negative. Okay, so if something's not matching, it's going to be negative. If they match, positive, positive, negative, negative, they will be positive. So that might be the easiest way to remember that. It's going to be very important. This is a very elementary base base foundational information. I'm using these words, it's basically saying this is the beginning of your math. You're going to understand basic things that are going to build into much bigger things as you move into other areas of math. So these things are elementary, they're fundamental. You need to know them. If it takes you a couple of seconds to remember them, if you need to reference them, then you're going to need to reference them. But these are very basic things. It's sort of like saying when you write the word cat, all right, C-A-T. All right, we understand how to say the letter C and how to say the A and the T. Okay, but if we wrote the word race, all right, we change here the A the way it sounds. Now, why am I using English or vocabulary? Well, again, it's very simple. You see the word here. You know there's no E at the end, and you understand the rules. Cat, and you understand here. Oh, there's an E at the end. Race. Math has its own rules, and you need to learn the language of math. And part of that, in a sense, is how symbols and how they correlate or How do they affect each other? The same way that the symbols of English, uh, how they affect each other as well. So let's move back over to our textbook. We're in the middle of page 131. Now, what happens when both of the numbers being multiplied are negative? Well, that's what we're going to talk about here. To find out, let's imagine that the moon is moving towards the Earth. Now, we're going to change the scenario. Okay, we're just going to change. We had F. Let's remove this real quickly. And our original scenario, we were talking that the Earth was actually moving, which it is, farther away. Okay, so we had, let me clean this up here. Some of you like a nice, clean, pristine board. And so we had our original formula was y is equal to 4x. Okay, and we had our table. Every time we put in a positive number, we received a positive number. Why? Because we were multiplying by a positive number here, right? 4 times 1, 2, 3, positive number. Now, if we put a negative number, it changed it to negative, which meant that the distance changed. It was going in a different direction, right? All right, so at least in a different direction, say from the original point. Remember that point of reference 0, 0. Now, let's go and take a look at this. And what they're going to do is they're going to change it. They're going to change the formula. And this is just hypothetical. What if it was the other way around? What if the moon was moving closer to us? What would that mean? Well, that wouldn't really be good, okay? Because the moon's coming towards us, and I guess eventually over time, well, there's 240,000 miles to cover 4 feet at a time. I don't think we'd have to worry about it in our lifetime, but nonetheless, it wouldn't be a good direction for it to be moving. So let's see what it means mathematically. And it says here, to find out, let's imagine that the moon is moving toward the Earth instead of away from it. Look again at the formula for the moon moving away from the Earth. So we have that y is equal to 4x. Now, if 4 in this formula is the rate at which it is moving away, which is positive, 4 feet per year, that's positive. So we're adding the distance. So, okay, it's if we were to be technical, let's say if it was exactly 240,000 feet, sorry. And then that means next year it will be 240,004 feet, okay? So 240,000 is where it's at today if that were the distance, and next year it would be more, right? So if the moon were moving at the same rate in the opposite direction, the 4 would become negative 4, and the formula would become, okay, now we would have a distance. And again, this is the hypothetical one. We're just making up another scenario, okay? This is, let's just say this is true over here. We know this to be true. At least we knew it to be true in 1979. We all know about science, right? Science is true until it's proven wrong, and then they rechange it and they recalculate everything, okay? But this is hypothetical, okay? This is just for math purposes. Let's say hypothetically it was coming towards us. Well, that would be different. Oops, excuse me, got to put my 4 in there. So we have 240,000 miles. And I said it right this time, huh? 240,000 miles. And that means, we would have to subtract 4, so it would be 239,996, would it not? Okay. And I'm saying if it were exactly at this point, this year, next year, it would be closer. And again, you could see that this is a much better scenario, at least for the Earth, because it would be moving away and not moving closer. You could certainly calculate how many years it would take before the moon and the Earth collided. I'm sure mathematicians would say it would increase in time, the distance, because of the force of gravity. But we won't go there. Before we could ever study that, we need to understand what we're doing here with some of the more simple formulas. So, because, and I'm back in my text, 131, because the Earth and the Moon would have been farther apart in the past and would be closer in the future, the second row of numbers in our original table would be reversed. Okay, now we see things changing here. We see the negative 3, which was once negative 12, now becomes positive 12. Negative 2 becomes positive 8. Negative 1 becomes positive 4. 0 remains 0 because it would not matter. 0 times anything is 0, neither positive nor negative, because 0 can be neither positive nor negative. But let's see what happens with 1, 2, and 3. They now become negative 4, negative 8, and negative 12 respectively. So as we look at this, we see our graph has changed. Look at the graph on page 130, where you see the slope is actually going up from left to right. Now we see the slope going downward from left to right. And we see that this is a graph of the moon moving towards the Earth. Okay, so again, this is just being hypothetical. We can see that we had to apply the knowledge that you may have already acquired about multiplying positives and negatives and negatives and negatives. And in this case, we have, well, we had the same negative positive at one point, right? Because we had 0, 1, 2, 3. So when we multiplied negative 4 times 0, well, we have 0. Negative 4 times 1 gave us negative 4. So we had a negative and a positive. Negative 2 would be negative 8. So again, negative 4 times positive 2. But if we go back and look at the negative 1, we were multiplying negative numbers times negative numbers. We had negative 1 times negative 4, and they were yielding positive. So let's flip over into our next page and discuss a little more of that. The formula says that each y number is always negative 4 times the corresponding x number, which means then, and again, we're talking about the graph to the left of 0, not the graph, excuse me, the table. We have negative 12 is equal to negative 4 times negative 3. So negative 4 times negative 3 yielded a positive 12. And below, negative 4 times negative 2 yielded 8. And so forth. So, oh, excuse me, positive 8. So we multiply negative and negatives. And again, just that little reminder, if they are of the both negative or both positive, the answer is always positive. If one is negative and the other is positive, then we would then have a negative answer. In these examples, the product of two negative numbers is positive. Although this may seem like a strange result, there are many other patterns that lead to the same conclusion. And again, the product of two negative numbers is always positive. Now, we've discussed this, and we can see the scenario where what would mean, going back to page 131. Let's discuss why that makes sense. Why does negative times negative make sense? Well, let's take a look again at our table. We have negative 1 times negative 4 is 4. If we were to go back in time, okay, this would have been for positive 1, okay? Now this would have been for negative 1. What would our distance have been? Okay, it would have been 2,000, oh, excuse me, there we go again, 240,004 miles. Because this would have this would have been our x value, right? Our y value would have been positive 4, which means that in reference from today, the Earth and the distance between the Earth and the Moon would have been 4 feet more, 4 feet farther. Okay, so negative 1, meaning 1 year less, 1 year ago, back in time, it would have been times negative 4, because remember the negative 4 is telling us the rate of change. It's for every year it's getting closer. We're reducing it over here, so we see that here. So obviously if we're going back in time, it's increasing. So we went from next year to today, it would have been 4 more rather, and from today to last year it would have been 4 more. Okay. Now, we typically don't see things in that way because we think of time. We're always adding. So let's say our age, well, in 1 year, we'll be 1 year older, right? But we don't think of time in terms of something increasing. But in this case, it is. Scientifically, something could possibly be becoming smaller as time goes forward. Okay, so this is why we have this, this formula. And because we can always go forward, and as we did, we went forward 1, 2, 3. So we were in the first scenario, okay, we were plus 4, plus 8, plus 12. But 1, 2, 3 in the second scenario, which is this one, the negative 4x, became negative 4, negative 8, negative 12. Okay, so we understand that. But that also means that when we go back in time, things would be different as well, because if it was constantly moving at a certain rate, we could certainly measure it in the past. And again, the constant rate of negative 4 means that if we go back in time, it would be a greater number. It would be positive, which then again tells us that when we multiply the negative times the negative, it will yield a positive. Okay? And whether you truly understand that, it would be nice if you did, if you really understood it from this application, how negative times negative works. But if you don't, if you sort of still have that little fuzzy understanding of it, that's okay. Just remember, negative times negative will yield a positive. Positive times positive will yield a positive. And when they're different, negative, positive, positive, negative, they'll be negative. Okay? So that's the end of this lesson.